Good afternoon, ladies and gentlemen. This is Unit 6, Day 4, okay? We got one more lesson in this unit, and that is pretty much it for the unit, okay? So, as far as new stuff, this will be the last day we're talking about new stuff, okay? So, have your calculator ready, all right, because we're going to be utilizing that. But, anyway, here's what we're doing today, right? So pretty much more solving equations with logs, okay? So pretty self-explanatory in the title, all right? But we haven't talked about this guy here, and this is the last piece I want to talk about, okay? Didn't realize that was so big there. There we go. All right, so it says star, star. Remember, if E is involved, use natural logs rather than common logs, okay? So in your calculator, all right, so I'll zoom in over here so we can have some space. Okay, and let me draw a quick graph here. Okay, so if you go to your calculator, I want you to put in a couple equations. I want you to put this guy, y is equal to e to the x, and y is equal to the natural log of x. Okay, and so if you do that, and go to your y equals. Now, your E is located right above the ln in your top or your bottom left-hand corner. All right, you're going to have to hit second and then E, and you should get some E with some caret symbol, and you just put that x inside the parentheses. Okay? So anyway, when you plug this into your calculator, okay, and you go to graph, what you get is you get this graph for your y is equal to e to the x, okay? And then for your other graph, you get this image. Okay? Which is the natural log of x, okay? Now remember, all right, when we're talking about the natural log, okay, what we have to remember is even though we don't see it, okay, our base is E. Okay? And so, what I'm trying to emphasize is this. The relationship between these two angle measures is that they are inverses of each other. Okay? I'm not going to put that, but they're inverses. Okay? So, that being said, right, the reason why I'm mentioning that is because when we go to solve equations that have natural log or E in them, we have to use the fact that E or natural log are inverses of each other in order to solve these problems. Okay? And so, zoom out of here. All right, and so let's take a look at our first problem here. Okay, so our first problem states that e to the x is equal to 217, right? So remember, e is an actual number, okay? We'll just put, well, e is actually, let me go to my calculator here. I type in e is equal to the number 2.1, oops, I'm sorry, 7, 1, 828, 1828. Okay? And it's a irrational number that goes on forever, okay? There's no pattern, okay? So anyway, that's what this number is. So we're saying this number, this 2.17, raised to some number x is equal to a nice, cool, flat 217, okay? And so how do we find that answer? Well, in order to find that answer, we're going to have to take the natural log of both sides. Okay, so when you take the natural log of e, what happens is, because they're inverses, they cancel out, and you're left with x is equal to the natural log of 217. Okay, so the concept goes kind of with our, when you're dealing with squares, right? How do we get rid of a square? You take the inverse, right? Or you take the square root, and it sort of cancels that out, and you're left with plus or minus 3. Okay? And so they're inverses because it sort of undoes the action of the other one, right? When if you have a radical, let's say I had, let's say it was, well, square root of 6 is equal to, I don't know, we'll just go 5x or something, right? Okay, so some number times 5 equals that. And so how do we find that? Well, we're going to have to square both sides. So we get 6 is equal to 5x squared. Oh, I'm sorry, 25. Well, either way, what I'm trying to emphasize is this, right? This e and this natural log sort of treat like you would your squared and your square roots, right? They sort of just undo the action of the other. All right, so that being said, erase this down in there. Okay, put a little bubble around here. All right, basically, x is equal to the natural log of 217, and that answer is 5.379897354. Okay? And so if you wanted to check, right, we're going to go e raised to that number. And by doing so, you're going to get 217. Okay? So it checks out. Right? So that's what you do if you have an e in there. Right? But what if you have a natural log? Right? Same sort of pattern, just we're raising it to something different, right? So before you can do anything with e here, all right, we need to get this natural log of x by itself, okay? So in order to do that, we're going to divide both sides by 16. So I get the natural log of x is equal to 30 over 16, which is actually equal to, 1.875, and then we'll take the e of both sides here, okay, your Euler's number. So by doing so, that cancels. I'm left with x is equal to e raised to the 1.e75. And we actually have that number, right? So e raised to that number is 6.52081912. Okay? And again, right, what we just found there, right, if we go back up to what we had here, natural log of x is equal to 1.875, we found that e raised to this power is equal to that value of x. And in this case, our value of x is that guy right there. Okay? All right. So pretty much the rest of these, right, besides those two new topics there, the rest of them are going to be pretty much a review of what we've covered thus far. Okay, so I'm going to go through all of it. Okay, it's probably going to be a lengthy video here. The only new ones, or the only new material that we are focusing or mentioning in this lesson is stuff like 1 and 2, just involving e or natural log. All right, but basically, if you remember, okay, anytime you have a natural log, your base is always just e, okay? And that's what we found right down here, right? So you have it written like this, and you convert it back to an exponential function. Hopefully that makes a little more sense. All right, number 3. Okay, so this is like case 1, right? We don't have any logs here, so I'm going to have to isolate this guy right here first. So that'll be 81. Then I'm going to take the log of both sides. So I get the log of 3 raised to the 4 minus x to the log of 81. And I use the power property. And I bring those guys to the front. Then I divide by log of 3. Okay, just trying to get this guy by itself. All right, so this is an actual number here. All right, so I guess I will solve that out. All right, so log of 81. Okay, and so I'm getting, I actually get an actually pretty nice number here, right? 4 minus x is equal to, well, 4. All right, so subtract 4, I get negative x is equal to 0, divide by a negative 1, divide by negative 1, x is equal to 0. Now, we have to make sure that that doesn't give us any extraneous roots, which it doesn't. All right, and so if you plug this in, okay, it makes sense. 3 to the 4th power, all right, so if you plug this back in there, right, 3 to the 4th power is 81. And 81 minus 7 is 74. Okay, so we're okay there. Let's go over to the next one. All right. Now, they didn't tell us what our base is, so we have to assume that it's a 10. And so now that I know that, I'm going to put this in exponential function, or put it in an exponential function. So then I get 100 is equal to x minus 1 plus 1. X is equal to 101. Let's go down to number 5. Number 5 got cut off, so let me put this one in there. So if you didn't get to this one yet, there is what I was supposed to say. All right, and so anyway, before we do anything, I got to combine these guys over here on the right. Okay, because we're adding between those, it's going to be multiplication, so log of 3x. And then because we have the same base, here's 10, base of 10, right? 10, base 10, because it wasn't written there. So we drop the logs. And that's x plus 3 is equal to 3x minus x minus x. I get 3 is equal to 2x divided by 2 divided by 2. X is equal to 2/3. Okay. Number 6, we have no logs here, so I'm going to take the log of both sides. So we have log 2 of x plus 3 is equal to the log of 5. Bring down that x plus 3 using the power property. Okay, divide by the log of 2, divide by the log of 2. And then just subtract 3. Okay, so x is equal to the log of 5 divided by the log of 2 minus 3. So what does that equal? I'm getting a negative 0.67, and we'll go 8, 1. Okay? There's our answer to that one. Let's see if I can drag that over here too. I mean, put it so close to the edge. There we go. All right. Try number 7. Okay? Natural log, which means I'm going to take the e of both sides in order to get that natural log to cancel. So that goes away. Left with 3x is equal to e to the 8 To get x alone, I'm going to divide that by 3. So x is equal to e to the 8 divided by 3. .993.65266. Okay. Here's 7. 8, you're going to solve the same way. Take the e of both sides. So this x is equal to e raised to the negative 1.1544. And e to that power is equal to 0.3152467. This guy here, we're going to have to combine these guys first, so we're going to multiply these two, so it'll be 6t squared is equal to log b of 24. Okay, drop the log, so 6t squared is equal to 24. Divide by 6, divide by 6. T squared is equal to 4. And just like with the linear, or the natural logs and the e's, you want to take the square root of t squared to get that to sort of cancel. So I'm left with t is equal to plus or minus, not 4, 2. Okay, now we have to check and make sure, do we have any extraneous roots? Because what this is saying is 2 is equal to a positive 2, 2 is equal to a negative 2. All right, so negative 2 won't work because if you put a negative 2 in here, you're taking the log of, well, of negative 4 and negative 6. Those do not exist. So our only answer is t is equal to 2. Okay. Number 10. All right, we're going to have to work backwards here. So I want to get this written as so it's just a single log. So I'm going to take this guy and put him back on that 9x. So log of 9x all raised to the 1/2 power is equal to 3. Okay. And then, knowing that this is a square root, I'm going to go log of the square root of 9x is equal to 3. Now we don't know our base, or at least they're not showing it, so we have to assume that it's a 10. So what we're looking for here is basically 10 to the 3rd power is equal to the square root of 9x. All right, and in order to find this answer, I take both sides and I'm going to square it. So this is going to be 10 to the 5th power is equal to 9x. And then to get x by itself, divide by 9. So our answer is that guy right there. Let's go to number 11. Again, natural logs, we're going to have to use some form of e here. So before I can do that, I need to get this guy by itself. Negative 5, divide by negative 2, divide by negative 2. So now I have natural log by itself, and I got a positive 5/2. Remember, 2 negatives equal positive. And then I'm going to raise both sides to that e, and what that does is it gets that to cancel. And so you're left with x is equal to e raised to the 5/2, which is equal to 12.1825. Okay, number 12. Log, same base. So we can drop the log. So x squared minus 1 is equal to 8 plus 1 plus 1. X squared is equal to 9. Square root. X is equal to plus or minus 3. And because we're taking that x value and we're squaring it each time, we will not get a negative number or a 0 inside that parentheses there. So if I plugged in negative 3 here, we get negative 3 squared minus 1 would be the same as if you had 3 squared minus 1. Both cases, you're going to get 8. And then, right, we're going to have log 2 of 8 is equal to the log 2 of 8, which checks out. Okay, 13. All right, let's convert it into an exponential function. So 4 to the negative 3 halves is equal to x. So 4 raised to the negative 3 halves. X is equal to 0.125. Okay, 14. I'm going to divide by 6 first, okay, just to make life a little easier. It's not going to be incredible, but definitely want this guy on the other side. Okay, so now, because I have it on the other side here, I'm going to take the log of both sides. Okay, so we're going to have log 4 9x plus 1 is equal to the log 21 over 6. Okay. Next, I'm going to bring down that expression. So 9x, make this smaller here, there we go. 9x plus 1 times the log 4 is equal to the log 21 divided by 6. And then to get x by itself, I'm going to divide by the log of 4. So we get 9x plus 1 is equal to whatever this nasty number is going to be. So let's catch up here. So the log of 21 divided by 6, all that divided by the log of 4. And I get 0.903677. We'll go 5. All right? And so I add 1, add 1. So we get 9x is equal to 1.9036775. Divide by 9. And eventually, x is equal to 0.21152. Okay, so if you want to check it, plug that value in for x. All right, let's see if this makes sense. 4 raised to the 9 times our second answer plus 1. Uh-oh. What did I do? 4 raised to the 9 times 0.21152 plus 1. Uh-oh. I'm not getting the same answer here. Hold on. Uh-oh. Uh-oh, uh-oh. 21 divided by 6. There it is. What did I do wrong here? So log 21 divided by 0.554. Okay. All that. Oh, divided by the log of 4. No, that's it. Okay. Oh, I added 1. You dork. There's the mistake. Jeepers. -1, -1. Ugh. Killing me, Smalls. Okay. So, there it is. Negative 0.096322. We'll go 5, 4. All right, and then divide by 9. There we go. divided by 9. Okay, so our answer is not what I had up there. I apologize. Negative 0.010703. Okay, so now take all that and raise it to that power, right? So we're going to go 4 raised to the 9 times our second answer plus 1 times 6, and we get 21. Okay, so you can always check these answers to be sure. All right, which I'm glad I did there, right? Because, yeah, a little arithmetic error there. All right, this guy here, okay, so I'm going to combine these guys. So log b, and this is the quotient property. Okay, and, well, 12 divided by 4, that's 3. 3k is equal to the log b of 15. Once we have the same logs on either side, drop the log, and just solve for k. And k is equal to 5. All right, well, let's see if that makes sense, right? So put that guy in there. What's 12 times 5? Well, 12 times 5, that's 60. And then if we plug those together, right, 60 divided by 4 is definitely 15. Okay? So, always got to check for extraneous roots. All right, 16. Put these guys together. Log b, 36 divided by 2 is equal to the log b of x. Drop our logs. X is equal to 18. All right, pretty easy one. 17, again, same base, same log on either side. Drop the log. 4x plus 1 is equal to 2x plus 5. Minus 2x minus 2x. 2x plus 1 is equal to 5. Subtract 1, subtract 1. 2x is equal to 4. Divide by 2, divide by 2. X is equal to 2. All right. Over here, okay, we got to get this piece by itself first. So I'm going to add 3. Okay, divide by 10. All right, and then we're going to take the e of both sides. So raise both sides to that power of e. That goes away here, so 100x is equal to e to the 12th. Divide by 100, and we get e, or x is equal to e to the 12th divided by 100. It's 1627.55. Gosh, are we almost there? All right. This guy. All right, 2 to the 5th power is equal to x plus 1. All right, 2 to the 5th, that's 32. X plus 1 minus 1, right? 31 is equal to x, which makes sense, right? Because if we put 31 in there, 31 plus 1 is 32, and 2 raised to the 5th power is 32. So it balances the equation out. All right, this guy here, uh-oh, not liking where this is going. Well, we'll see what happens. We got to get this piece alone. So log 3 of n plus 3 is equal to 0. And so 3 to the 0 power is equal to n plus 3. And that's just equal to 1 is equal to n plus 3. So minus 3, n is equal to negative 2. Does that work? Sure does. Negative 2 right in there just gives it a, well, just equals a 1. Okay. All right. And we'll save the bonus for class. All right, so challenge. What do you get for that? Give it a shot. Chickens. Just kidding. Maybe nobody's even watching this. But if you are, give it a shot, turkey. All right, I'm done calling names. But if you think you got it and you want to impress Mr. Kaya, give it a shot. All right, have a good day.